In this video, I am going to teach you computer graphics and its algorithm. So, first of all, you need to understand what is computer graphics. Computer graphics involves display manipulations and storage of objects and experimental data for visualization using computer. So if you want to visualize like some experimental data, you need computer graphics. So this is basically definitions, and you can get better definition from book. Actually, in this video, I am going to tell you the algorithms for computer graphics. First of all, let's talk about line drawing algorithms. So how you can identify lines? There is two equation, y equal to mx plus c, and so there is two equation by which we can easily denote a straight line. That is y equal to mx plus c. So this is the equation, that is its line equations, and m is the slopes and c is the intercept on y-axis. So this is basically line equation, and another equation was there, and this is actually if there is 2 points and is a line passing through 2 points, say p1 equal to p1 is x1 and y1, and p2 that is x2 y2. Then if the line is passes through these 2 points, then we can easily calculate its slope, and the equation of the slope is m equal to y2 minus y1 divided by x2 minus x1 by x2 minus x1. So basically a line equation can be written in terms of this equation, that is y equal to, we replace the value, substitute the value of m, that is y2 minus y1 divided by x2 minus x1 into x plus c. Plus c. So this is the basically line equation, and we can easily get the value of c from this equation, that is c equal to x2 y1 minus x1 y2 divided by x2 minus x1, x2 y1 minus x1 y2 divided by x1 minus x2, sorry, x2 minus x1. And this is the value of c. Okay, so now substituting the value of c, again we modify our equation of line, and we get the final equation as y equal to y2 minus 1 divided by x2 minus x1 into x plus x2 y1 minus x1 y2 divided by x2 minus x1. So we get final equation as y equal to this part plus C part. Okay, and the C part is very simple. So yeah, this is we get by deriving the line equations. If the line is passing through 2 points, it is p1 and p2, and the coordinates of p1 is given as x1, y1, and the coordinates of p2 is given as x2, y2. So now algorithm for polygon line drawing. This algorithm takes 2 points. So I write algorithm polygon line drawing. And this algorithm takes into this the 2 point through which the straight line is passing. So you have to give the p1 points and p2 points, that is the 2 points on the line. So it's basically taking the input from the user in order to draw the line, and you can easily see the algorithm. So algorithm starts here, so I place a bracket, and now the algorithm is a equal to, now the algorithm is actually written. I am considering that the algorithm is written can be written in MATLAB. So I am using this format 0 to 55 cross 255. This is basically for the purpose of selecting the region to fill black, and x is equal to x1 and y is equal to y1. So now c equal to, easily write c equal to what was the formula, x2 y1 cross product, like cross product x2 with x2, we consider y1, and with y2 we consider x1. Okay, x1 is whole divided by what, x2 minus x1. Okay, similarly we can calculate the m. That is m equal to this one. Okay, m equal to this one. So let's first calculate the m, after that c. So cut that and test it out. So, and cut that and test it out below. So now we can easily write the y. Okay, so we get y equal to mx plus c, m is calculated, and x plus c, and whole value is calculated. Now write a method set pixel x comma y. Actually, here we take one points. Initial points is within this. Okay, x1, y1. The initial points. That is the 2 points. 2 is the straight line is going to pass, which initialize it with this. So now we calculated m and c and then y. So y value is basically updated every time. So the question is that you can put set pixel here. You can also put set pixel here. Okay. You can also put set pixel here. And after calculating this, you can put set pixel. Wait. First I am writing the whole algorithms. Okay. X2 x is equal to x plus 1 z1 equal to x plus 1 y equal to y equal to x plus c. Okay. Now m is here is constant, c here is constant, and we calculate m and c in the above. So now you can use set pixel x comma y in order to set that pixel here while loop ends. The algorithm also ends. So this is basically very simple algorithm. So here you need not to write the set pixel. Okay, basically this is the initialization point. You put set pixel here and calculate the constant value, that is m and c. Then we update the y. So after updating y, yeah, you have to put the set pixel here. So after updating y, again you print y. Okay, again you print y. So basically, given a value of x, you calculate y, and it's the initial points. So you can eliminate this pixel also, because given a value of x1, we calculate the y1. Given a value of x, we calculate the value of y. Then you put the set pixel method. If you put set pixel here also, there is no problem, because you initially set pixel the point, the starting points, and then update the value of y, then again print this set pixel, that is x value is same here, but y value is updated. So you get to different points. After that, you constantly checking whether x raised to x2, updating the y, set pixel method, make it line. So the application. Now let's talk about the application of this algorithm. So there are various applications. First of all, any type of object that contains straight line and draw with these algorithms. Rectangle object or triangle object or rhombus, any types of object that contains straight line and figure, you can easily draw them with this algorithm. In Java, there is drawline method, and drawline method takes the same. That is, drawline method takes the starting coordinates and the ending coordinates and is draw the line. So basically, the drawline method in Java language is implementing this type of algorithms, not exactly this, because there is more precisely algorithm. There is some drawback is lies within these algorithms. So after some study, we can easily understand the drawbacks of this algorithms, why the better algorithm comes. So the drawbacks of this algorithm is here you get a floating point operations in this line and in this line, so it is totally time consuming because you have to take care of precisions and so many things. So this is basically time consuming because of floating point operation. Now let's talk about DDA. There is digital differential algorithms, and it's also a line drawing algorithm. So in application I write draw object, and in drawbacks I like drawback I write a floating point operation. Floating point operation. Okay. So our next algorithm is DDA, that is digital differential algorithm. So before writing the algorithms, let's derive the algorithms. So there is basically 2 points, starting points and the end points, as we write earlier. That is P1 and P2. So there is 2 points and there's 2 points. Okay, that is given to the algorithms. Now the algorithm calculate the delta x, that is how deviations between the x coordinates. Say you have given x1 as 3 and x2 as 10, so you can easily get delta x. Alright, del x that is equal to x2 minus x1. Actually absolute value. Okay, absolute value of this two. Absolute value of x2 minus x1. Similarly we get del y. Similarly we get del y, that is equal to y2 minus y1. Now we have consider the x interval delta x as 1. Now consider the x interval delta x as 1. I am considering that delta x, that is in pixel, delta x is delta x is 1, and you can easily write that m equal to del x by del y, del squared by del y plus z by del y. So but I am writing that del y is equal to m del x. Okay, sorry, this will be del y divided by del x, and by multiplying that is called del y equal to m into del x. M into del x. So if del x is equal to 1, and that is I am considering here, so this equation becomes del y equal to m. Equal to m. Okay. Now we can easily write del x as x equal to x I plus 1. This is great. Let x I plus 1 minus x I and yi plus 1 y I plus 1 equal to y I plus m, because m equal to del y and del y equal to yi plus 1 minus y. So we get the two equations. Depending upon the value of m, we either choose del x as 1 or del y as 1. So if mod of m, that is mod of m is less than or equal to 1, then we get del x as 1, x plus I equal to x I. So del x, consider del x as 1. Sorry, plus 1. Consider that del x as 1. Y plus 1, that is equal to yi plus m. Now you can repeatedly calculate yi plus 1 value from the previous value of yi plus m. So you repeatedly get so you can repeatedly get x value and y values. Okay, and we can repeatedly get equations of the line as y equal to m, initial y equal to mx plus c, and after that we calculate y1 from y and calculate x1 from x, and we write y1 plus 1 plus c, and similarly we do this type of things. So in the set fixer method, we put x coordinate or y coordinates. Okay. Now if delta m is greater than 1, if delta m, absolute value of m, is mod of m is greater than 1, then we choose two things. Okay, then we choose two things. What was that? Choose the delta y as 1, but we don't choose delta x as 1, but choose delta x as 1 by m. So we are basically writing y I plus 1 minus yi equal to 1 and xi plus 1 equal to xi plus 1 by m. So now we can easily update. Same here, we get the repeated equations, line equation here. So we get the various points x1 y1 x2 y2 and put the set fixer. So let's now write the algorithms. Okay, DDA takes three values, four values, x1 comma x2 comma x1 comma y1 comma x2 comma y2. So the algorithm starts here. First is initialize. No need to initialize here. So you easily calculate delta x equal to x2 minus x1 and delta y equal to y2 minus y1. And after that you can easily calculate m. If delta y, that is del y, is less than equal to del x, so we have the smallest term in the numerator and largest term in the denominator. So the value of m is basically less than 1. Okay, less than or equal to 1. So we take the steps of delta x here. Step equal to del of x, else step equal to del of y. Previously I am saying that if m is greater than 1, then we take the delta y as 1. So we take the step of x. So now we increment, we define x increment inc equal to delta x, that is del x, calculate the deviation from one point to another point, divided by step means step is also nothing but delta x. So we get x increment as 1 if m is less than 1. If m is greater than 1, so let's say step is delta y. So in this case step is delta y, so we get s increment as 1 by m, because 1 by m equal to delta x by delta y. If m is greater than 1, we get y increment equal to delta y divided by step, and here step is delta y, so y increment will be 1. So basically is nothing. The algorithm is so simple. First we calculate delta x, delta y, then we define x increment and we define y increment. Actually firstly we calculate delta x, delta y, then we update the delta y or delta x depending upon the m value. Now set pixel x1 comma y1. Initial value, so next I initial value, then with the for loop or while loop update the value of psi and get share with step. Okay, so after how many points iterate is basically deviation. So if we start from x1, again is the right x1, but here we are starting from 1, so you can maximum go up to step. There is a deviation between either in x coordinates or in y coordinates. So here we update the value of x and y. X equal to x plus x increment, and y equal to y plus y. Now check pixel x comma y, and this is running in a loop. The algorithm stops here. That's it for today. Thank you guys. Don't forget to like and subscribe my channel. Thank you for watching.